right, so normally, I started thinking about this, and normally people get to this section and they're like, sweet. Love this section because we covered it so thoroughly last spring. However, I know how that went. So, and I got a taste of how that went when we just did analytic trig, and people still don't know identities and stuff. So, the hope for all of this is that you'll be in good shape, but you may have to kind of do a little bit of overtime, maybe this weekend, making sure you memorize these formulas, because I will give you nothing in the way of formulas. Now, there's not a zillion of them, but what we're going to be talking about today is law of sines and cosines. And you should have talked about law of sines and cosines with Mr. Helmers, and we did talk about it last year, and I'm pretty sure it was once we were all at home after March 13th. So we're going to have to take a look and make sure that you're in good shape with law of sines and cosines, all right? Now, normally I spend my time kind of showing you the proof of it and all that. And if we have time on a review day and you really care, I can show you where the proof comes from. It's a little laborious, but it's, at least for law of cosines, law of sines is not that big of a deal. But I'm just going to go ahead and give them to you, and then let's just start talking about them and how we can actually use them to solve situations. Now, the hardest part, in my opinion, about law of sines and cosines is dealing with what we call the ambiguous case. And I'm going to get to that. But the first thing I want to talk about is when you would use the law of sines and law of cosines. So first of all, here's law of cosines. Anybody remember this? There's three of them, but they're all kind of similar. The law of cosines says, I'll just start with the c squared one. C squared equals a squared plus b squared. Starts looking like Pythagorean theorem. And then it goes minus 2 times the product of the a and the b times the cosine of the angle opposite this side. All right? And then you could always have the b squared equals a squared plus c squared minus 2ac times the cosine of angle b. And then, of course, you could have a squared equals b squared plus c squared minus 2bc times the cosine of angle a. But the angle and the side right here are always opposite each other. And when you think of when is a good time to use this, we're going to use this to solve equations that aren't right triangles. I've already got a great plan for right triangles. It's called trig, right? If it's a right triangle, I can find anything I want using Pythagorean theorem or simple trig, opposite, adjacent, that kind of stuff. But if it's not a right triangle, if it's some random oblique triangle, like maybe that, and I have that angle and maybe this side and this side, okay? And I have the ones that are in purple. I'm going to go ahead and circle those like I actually we're given these. But what I don't have is, say, this side over here. And by the way, you know that sides and angles will be matching letters. Like the angles are capitalized and the sides are lowercase. So that would make this angle C and this angle B. Now, if I'm given these three things, what kind of... It's off?
Yeah, you're off.
Dadgummit. Why's it doing that? That breaks down. Yeah. Let's go.
A little bit, like the side structure.
Oh, yeah, thank you for that. All right, thank you. So, if I'm given a situation like this, right, with law of cosines, if I know 3 of the sides, what would you call this situation? Not 3 of the sides. If I know these 3 pieces of information, what do we call that? Side, angle, side. Not because of the order in which they were given. Like I could give this to you like this. B, C, and angle A. Don't look at this and go, oh, side, side, angle. Has nothing to do with the order in which they're given. It has to do with the way they're connected. The information is connected. So when I see a side connected to an angle, connected to a side, that represents a side, angle, side. And anytime I am given a side, angle, side situation, you're going to want to start or begin the process using a law of cosines. And when you look up here at the equation, think about it. if I'm given angle A, I'm going to want to use this angle A equation. And if I know B and C, I know everything I would need to know on one side of this. So it would be very easy to plug that information there, plug the angle there, type all that in my calculator, or if you were lucky, manually if the angle was nice, and then just square root it all. Are you with me? So side, angle, side, begin with law of cosines. Now there's another situation that works great with law of cosines. Do y'all remember it? Do what? Side, side, side. So side, 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 obviously, is when you're given three sides like B, A, and C, but you don't know any of the angles. So I would not know A or C or B, right? But if I know those three, and say I'm looking for angle A, right? So say I'm looking for this. Kind of like before, I might have been looking for that. If I'm looking for angle A, well, I tell you what, let me look for a different angle. Let's just say I was looking for angle B. So if I'm looking for angle B here, I would want to use this equation, right? And I would take all three sides and plug them in. And if I did that, you can see I would know that side, I would know all of these sides. Now, it shouldn't be too hard to solve for that angle by subtracting the a squared over, subtracting the c squared over, and then dividing the negative 2ac over. And that would leave you a cosine of b, and then how would you solve cosine of b? Inverse cosine. And would you ever worry about inverse cosine giving you lies, bad information? Why not? Yes, because inverse cosine is defined between 0 and 180. And I'm finding angles. And what's the biggest angle in a triangle? I guess in theory something smaller than 180, right? So I have no worries about this. Law of cosines is my friend. Think of a law of cosines like a nice golden retriever. Maybe a sweet labradoodle, right? You can whack them, beat them, kick them, pull their hairs. No, I'm not suggesting to do that, but you know, like little kids, wham! They just whack the dog and the dog's like, I still love you. I mean, it's just a really nice, wonderful dog to have in the house. They're just continue to come back to you. Hey, they're kind, they're sweet, they're loyal till the bitter end. I know I just sadly had to say goodbye to my labradoodle over the summer after 14 and a half years. Wonderful dog. I know, it's awful, man. Wept like a baby. I was like, I didn't cry about anything. My dog. But anyway, my point is, guys, focus. Law of cosines will not lie to you because it's using inverse cosine. And when you're solving for angles, you get into trouble sometimes using the two formulas we're talking about today. Because one of them is law of cosines, but one of them is law of sines. And law of sines, when you're finding an angle, guess what you're going to have to do? Inverse sine. And what does inverse sine limit you to? Negative 90 to 90. So the law of sines would never allow me to find obtuse angles. It can't. The calculator will not spit it out. That's a problem for us. And we've got to learn to navigate that. But if I'm dealing with side, 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 or side, angle, side, you can start and finish, if you want, with the law of cosines. And if you continue to use it and never go back to law of sines, you're fine. Now, I have some people that really take me serious with that, and they're like, sweet, I'm sticking with law of cosines. And honestly, it's not like it's a mile-long equation, but it is a little longer than law of sines. And to me, I would rather know what I'm going to talk about well enough, or know what I'm going to do well enough, that I can use this when necessary, but because personally, law of sines is a little easier in certain cases. A lot of times when I'm forced to use law of cosines initially, I'll do that and find the side or the angle that I'm missing. Then I'll go back and start using law of sines. But you got to be careful because law of sines sometimes will give you false information because of the nature of the limitations on that inverse sine. And I'm going to talk about how you can use logic and one little rule to bail you out. So in your notes, there's a big long page on all the rules and blah, blah, blah. And that's great, that's solid information, but I'm going to do you a favor and just show you what small couple little things you can do to help yourself out to avoid trouble from the start. And I would rather avoid trouble than to get in the midst of it and then have to deal with it. Are y'all tracking with me? Okay, but remember, what is law of cosines? Golden Retriever, Labradoodle, super kind, will not lie, there are no limitations. And by the way, hear this. If I'm ever solving for a side, then I don't ever use I don't have to worry about inverse cosine, do I? Because when I'm solving for a side, I know the angle, right? So if I'm not solving for an angle, then I'm never going to deal with an inverse sine or inverse cosine. So none of the formulas lie when I'm solving for sides. But law of sines, you will see in a moment, will lie to you when you're using it to find an angle, but only occasionally. And if you're on your game, you can know how to deal with it. I'm going to put you on lock time out, man.
I'm just curious.
It's not that interesting. Come on, focus. All right, so here we go. That's law of cosines, and I'm going to come back and start showing you examples. Now, law of sines. Can y'all see this? Or is that too gray and boring? All right, so law of sines is really, instead of writing it in 3 different ways, people tend to write it with just one equation. So they could do something like this and say sine of angle A over side A equals sine of angle B over side B. And then they could write another one that says sine of A over A equals sine of C over C. And then they could write another one that says sine of B over B equals sine of C over C. But instead they just make one big equation to show that relationship. But you're not going to ever use all 3, right? You're going to use like this and this, or this and this, or this and this. But it's a ratio. And it says the ratio of the sine of the angles over their corresponding or opposite sides are always equal. And there's a proof to that that's not that big of a deal. Okay? Now, law of sines, I'm just going to use the A and the B example. There is no way to get side, side, side even into that. Think about it. If I know A and B and C, I can plug the A and the B in, I can't even get the C in, and I'm left with 2 variables. Never want to use law of sines, side, side, side in that situation. Now, side, angle, side. You might say, well, side, angle, side has 2 sides in an angle. I could do that. Well, the problem is, yes, you have 2 sides in an angle, but it's these 2 sides and their and their included angle. Those don't match, do they? Those letters. And if there's no match right there, then there's no way I can get all 3 of them in there, is there? So you can see here, side, angle, side isn't going to work here. Well, what's left? What other given situations would be left here?
Side, side, angle.
Okay, if I know a side like B and a side like C and an angle like angle B, yes, that is a situation that would work, and that is side, side, angle. And again, it's not how I'm listing them. If I list them B, angle B, C, that does not make this side, angle, side. It's how they show up on a triangle. And you can see it's going to be side, side, angle when you see a what? 2 sides an angle, but what? A matching letter. Because a matching letter means you have the angle and then the side opposite it. And if there's another side in there, whether it's C or A, you have side, side, angle. Now you can also say I have angle, side, side, but we try to keep it clean in pre-cal, right? So we're going to avoid that. So we've got side, side, angle. Somebody always like 20 seconds later goes, oh, yeah. And then figures that out. But anyway, side, side, angle, right? That means if somebody else do it. So I could use, if I have this information, look, I can plug the B's, like right here. I can plug the B's in, right here, there and there. I could plug the C in there, and I could use that to find angle C. Now here's the problem with that. If I'm using this to find angle C, is there a chance that angle C is an obtuse angle? Of course, because sometimes these have obtuse angles. And you're probably not going to be able to draw an accurate picture every time, nor do you want to. And if it is obtuse, in the process of solving, you would end up having to do inverse sine, wouldn't you? Will your calculator be able to give you that obtuse angle? No. But you're not going to know whether it's obtuse or not. I make a problem out, sometimes I put it on the test, where the answer the calculator gives you is 89.9. Now you're not going to notice the difference whether it should be 89.9 or 90.1. It's 0.2 degrees. You're not going to notice the difference. And unless you knew your rules and knew how to avoid maybe that situation, you could potentially get in trouble. So I'm going to go through all that, how to deal with it. And there's really only one case, we call it ambiguous case, of SSA that can get you in trouble. But we're going to talk about that later. Are you with me? Now let me ask you this question and have you start mulling this around. Does every triangle have to have an obtuse angle? No. So it's already, call it maybe 50-50, that whether one of them's obtuse or whether none of them are obtuse. Now if one of them's obtuse, can you have a second obtuse angle? No, because you can't have two of them bigger than 90. So at most, maybe you have none. And if you have none, no worries. But if you do have one, you're only going to have just one, right? So if I'm ever using law of sines, I'm going to try to never find the biggest angle with law of sines. And how can I know that it's the biggest angle? Biggest angles are always opposite biggest sides. So if you happen to look at this and you go, oh, it's very clear that C is bigger than B. Well, if I can, I don't want to use law of sines to find angle C. Because C being bigger than B means that C could potentially be the biggest angle. And if it is, it's great if it's lower than 90. But if it's bigger than 90, my calculator will lie. So law of sines, unlike our golden retriever labradoodle friend here, is like just a mean, nasty house cat. You'll go, hey, kitty, kitty, and just claw your face and leave a big scratch and then beg for food later. You just never know the temperament. Might be really sweet, purr around your legs, and you just never really know. Are y'all with me? So you have to know how to deal with this, or you're going to get clawed up a lot on my test. And nobody likes to get clawed up, right? I mean, having a little like red badge of courage is one thing, but it's like, dude, man, what happened? Cat clawed me. That's not cool, right? Gotta have a better story than that. Now, is there something else that would work with this other than side angle? Angle, side angle, or even, yeah, so if I had, say, angle A, say angle B, and really at this point, it doesn't matter which side. I could have this side, right? Sorry, I could have, trying to color coordinate these. I could have this side right here. This would be angle, sorry, this would be angle connected to side connected to angle. But it really doesn't matter whether it's that or maybe this, which would be angle connected to side. It doesn't really matter because if I know two angles, what can I always find without trig? The third. So when I know two, I really am going to know the third anyway, right? So in a sense, knowing two, I really know three, and at that point, these are kind of the same. So anytime I have two angles and just any other side, you can easily find the third one by subtracting those two from 180, and then you're on your way. And at that point, you never have to worry. I don't have to worry about getting lied to here. Why? Because I'm not using inverse sine to find an angle. I'm using these equations to find sides, because I have all the angles. So really, it boils down to this. This is the one that's dirty and nasty, and it's very cat-like. Okay? And I like a cat like the next guy. I don't particularly want them in my home because they claw your furniture up and stuff. But they're very interesting to me, and they're fun, and little kittens are fun. But the point is, they can be nasty, and we got to be careful. All right? Every other situation is very doable. Will not give you issues. But the ambiguous case of SSA, sometimes it's nice, Sometimes it's nasty, and you got to be prepared. Are you with me? Okay, now, the way to tell, again, SSA is two sides in an angle, but unlike this two sides in an angle where they don't match letters, these two sides in an angle will have a matching letter. And if there's a matching letter, two sides in an angle with a matching letter, that's an SSA situation. And you need to immediately get on your guard and be careful and try never, ever to have a situation like this where you're using law of sines to find the biggest angle. Now, I am going to show you what to do when you have no choice. When I give you one of these and you go, and that's all I have, my hand is forced. I am forced to use a law of sines to find the biggest angle. When that happens, and you're forced to do it and you have no other options, guess what? It's really not that bad, because you're still going to go ahead and plug in your calculator, and your calculator is going to tell you one of two things. It's either going to give you an answer, and when it gives you one, you know there are two. Or it's going to tell you error, which means there is no triangle at all from that information. Or you made an error somehow. All right? Now, let me show you a picture of what I'm talking about, and then we'll actually do some problems. So, right here, SSA, SAS, law of cosines, money, you can stick with law of cosines from beginning to end. The equations aren't that much harder if you do want to stick with them. But if you don't want to and you want to use this initially and then go back, no worries. I can talk to you about how to avoid difficulty. Here, never going to have issues with law of sines. Ever. Because if I know two angles, I can find the third. And again, I only have issues when I'm finding angles with law of sines. I already know them. Finding sides, no issues. This one is the one glaring red flag that you have to be aware of. So when you see two sides in an angle, and there's a matching side angle, which means they're opposite each other, that's when you got to get, the red flag goes up and you got to start being careful. Are you with me so far? So I'm going to just start throwing these at you, but I do want to show you a picture of this, of some SSA situations. So here's this SSA situation. Let me say that A is, we'll call it 10, B is 8, and angle A is 22 degrees. So I want to draw a picture of this for you and show you how this is a potential issue for you. Now, real quickly looking at this, I go, wait a minute. Hold on one second. No, B is 13. Now, looking at this right now, you know that this is SSA, and how do you know that? Two sides in an angle, but how do you know it's not SAS? Matching side right here, right? Matching side and angle. Now, in this case, if A is 10 and angle A is 22, B is bigger than A, what do you know about angle B? It's bigger than 22. Now, throw out that mentality of, oh, well, if B is really close to 10, that means angle B is really close to A. Not a true statement. The only thing that's true is, because B could be really close to A, but it also could be way bigger. All right? So when you look at this right here, what you need to look at this is, well, if B is bigger than A, then angle B is bigger than angle A. What does that mean then? It could be anywhere from, call it 22.1 all the way to what?
179.
Well, technically, if there's already 22 degrees in there, like 160, 158-ish. So could it be obtuse? That's a trouble situation then. And if you ask yourself that, wait a minute, B could technically be obtuse. I can't plug it in here. Look what would happen if I tried to plug it in here. I would have to use the angle A equation, so I'd plug that in there, and then I'd plug B in there, and B in there, and A in here, and what would I have to do to solve for this C squared C equation? You think you're going to be able to factor it after doing a cosine of 22 degrees and getting that ugly decimal? What would you have to do? You'd end up having to use the quadratic formula with an absolute disgraceful mess. Okay? You don't want any part of that. So in a situation like this, I'm certainly avoiding this, and I'm going to law of sines, but they're forcing my hand to use a situation with this right here where I'm going to be using sine to find the biggest angle. But I got to be careful, because if I recognize that it could be obtuse, that means there's going to be two answers or no answers. Now, it is possible that there's one, but the only way there's one, and you'll see this in the picture that I'm about to draw, is if it's exactly 90 degrees. And it won't be exactly 90 degrees, because if it was, these would all be special relationships, like 45 degrees, root 2 over 2, or something like that, or 60 degrees, and square root of 3 over 2, or 1/2. And I'm not giving you those, I'm giving you whole numbers. So for your work, 2 answers or none. So let's take a look. Look at this picture. So I'm going to draw angle A. I think I may have done this in the video last year. Would you kind of give me that this looks like a curve? That this looks ballpark like 22 degrees maybe? Maybe? Okay, close enough? Okay, so if that's 22 degrees, we'll call that A. I don't know where these lines are going, so I'm just going to put dotted lines right here. And this thing just keeps going like that. That's all really I know about this angle, correct? Now where would A be? Across from it, so somewhere over here, but I don't know where to connect it because I don't know how far these sides are going. Where would B be located? One of those legs. So why don't we just make it the bottom leg? So I'm going to make B this, and we'll just call that 13. And if that's 13, would you say that maybe something this long, maybe like from here to here, might be 10? Would that be fair enough? Or maybe like from here to there might be 10? Does that make sense? Okay, so if that's 13 and this is B, then if that was 10 where my fingers are, what if I rotated it up like a circle right here? What if I rotated it? It would hit right there, wouldn't it? And wouldn't that then be my, here, work with me. Wouldn't this be my A equals 10? Are y'all following me? Mm-hmm. So there's my picture. So that would be A, that would be A, and that would be B. And from there, I could plug it in there. Now, on this particular situation, B, it's very clear, B is what kind of an angle? Huge. It's obtuse, isn't it? My calculator can't give me that. It literally can't tell me what that is. But guess what else? Since this thing keeps going, isn't it possible when I rotate this thing all the way around, it also hits up here? And that right here could also be my A equals 10. So this could be one of the triangles that fits this information, and this could be the other one. So this potentially could be one B, and this could be the other one. But which one is your calculator going to tell you? When you go and plug this in and solve for angle B, it's going to tell you the smaller one, the one that's acute, because it's able to do that with inverse sine. Check it out. Hope I can fit this in here. So right here, I would go sine of angle A over 10 equals sine of mystery angle B over 13. And how would I solve this? You only get work for setup and answer here. So what would you be typing in your calculator to actually do this, guys? What would I type in? You probably multiply by 13, right? And when I multiply both sides by 13, that cancels. So I'm going to type that in my calculator. So here we go. 13 times sine of 22. Make sure you're in degree mode for this whole test, more than likely. And I am not. So I'm changing it. Does everybody know how to change from degrees to radians on this? Okay, so I'm going to do that and then divide by 10. And my calculator spits out, oh yes, my calculator spits out 0.48699. So that part right there gives me 0.48699, yada, yada, yada. And then what would I do to get rid of this? Inverse sine all of that. And when I inverse sine the answer, I get 29.14 degrees. So my first B is 29, right there is 29.14. But we know that there's two triangles whenever you're forced into this situation. Now guys, sometimes you're not forced. Sometimes you look at it and you're like, wait a minute, like for instance, what if A was 16? What do you know, 16, what do you know about B? If A is 16, what do you know about B?
Smaller.
It's smaller, and if it's smaller than that, you're not worried about it, are you? Using law of sines to find an angle that you know is smaller than 22 is no problem for law of sines, because inverse sines give you angles that are smaller than 22. You're great. Or if that was already obtuse, there's only one obtuse, you're great. It's the situation that we were in that we didn't know B could have been obtuse. If that's the case, you're going to have either no triangle or 2. And to have 2, your calculator is going to give you the first. And if this right here, do some geometry with me. If that's 29.14, then what do you know about that?
9.14.
It would have to be 29.14 also because this is isosceles, but that's not the angle I want. But if that's also 29.4, then what's this B2 that I want to find? 180 minus that. So all you got to remember is, hey, B1 is whatever your calculator gives me, and B2 is 180 minus that, which is 150.86. And once I have those two B's, you hear this, take this B, put it with this information, ignore this, take this one, put it with this, solve the rest of your triangle using this information. And then when you're done, take this information, put it with this, solve the rest of your triangle. Are y'all seeing that? Using law of cosines or law of sines, whatever you want. But you have no more worries at this point. Because if I have 2 angles, what do I already know? I can find the third with 180 minus. If I have this with this, I can find the third with 180 minus. And either formula doesn't lie to me when I'm finding sides. Right? That's the only one that gives you issues. And check this out. What if the angle was bigger than 22? Oh, by the way, what if this side right here, 13, is, this side right here, 10? What if it's really small, like 5? Tell me, what do you know about angle B? You still know that it's bigger than that, right? So is it possible that it's obtuse? So is it possible your calculator lies to you? But look at the picture here. If this is 13 and side A is 5 and A is too short and doesn't make it back when you open it up, it doesn't hit at all. Are you with me? Like this information right here, A is 5, right? B is 13. It's too small. You're not going to know that just by looking at this. I mean, you might have a hunch, but you don't really know. But when I type this in my calculator, guess what my calculator gives me when I have a 5 right here? It gives me error. And when your calculator says error, assuming you've done the math right, that just means there's no triangle at all from that information. Are y'all tracking with me? And then what happens in a situation like this? These are all SSAs. So would you have any concern about this? What would you say about this?
Impossible.
This is impossible. How do you know that? Because B has to be bigger than that. And if B has to be bigger than that, angle B, because side B is bigger, then angle B would have to be bigger than 97, which would give you 2 obtuses. Right? That can't happen. Now, sometimes your calculator, most of the time your calculator says error. But guess what? Sometimes your calculator actually gives you an answer. Sometimes when you go to solve this, you're going to get angle B equals 100 and, well, actually it wouldn't do that. It would do, what if I had something like this? It'll say angle B equals 79 degrees. And sometimes all I do is say, hey, find angle B. And you go and you plug it in your calculator and you get that. But wait, does that even make sense? Can 2 angles add up to give me 210?
No.
No. So you got to trunk that. Hopefully you don't even show me any work. Hopefully you look at this and go, that's impossible. DNE. That's what I hope I see. But if you do this, make sure you take a look and go, wait, that doesn't make sense. DNE. Are you with me on law of sines, how to use it? Now sometimes it's pretty basic law of sines and it's not ambiguous. Look, what if I give you this? A is 10, angle B is 27, angle C is 75. What if I give you that? You have two angles, right? So what can you immediately find? And that would be what, 90, 102, 78 degrees? Now, what would I be doing on law of sines here? What side would you want to find?
B.
Side B, so I'd have sine of angle B over B, sine of, say, angle A over A, and are you going to have any issues with law of sines? No, because there's no inverse sine involved. Cross multiply, solve for B. Or do the slide rule. Remember the slide rule? Or just cross multiply. Right. Now, back to law of cosines. I'm going to show you two situations for law of cosines real quickly before the bell rings. Check it out. What if I gave you A is 2, B is 3, C is 4? And I said find, or how about, yeah, C is 4. I said determine or find angle A. Now I have a question. What if I said find all the angles? Could I use law of cosines the whole time? I could. Y'all tracking with me? Because law of cosines doesn't lie. What if you planned on using law of cosines and then jumping to law of sines later? When does law of sines lie? When you're finding the largest angle? And wouldn't it kind of make sense if you knew you were going to do that, to go ahead and use this to find the largest angle? And get it out of the way. So if it's up to me, I'm finding that. So I'm coming in here, I'm going 4 squared equals a squared, equals 2 squared plus 3 squared minus 2 times 2 times 3 cosine of C. And how would I type this in my calculator? 4 squared, I'm going to be careful on this part. Subtract the 2 squared, subtract the 3 squared, and then how do I get rid of that? Divide by all of that. Now I would use a fraction button. And then when I'm done, how do I solve for the angle? Inverse cosine. Are you going to run into issues with inverse cosine?
No.
No. Are y'all with me? Hey, see what you can do. I know that was a lot to take in. We can talk about it tomorrow. We're going to do a little bit with area tomorrow also. But guys, really make sure you memorize these formulas well. Here are the mistakes in memorizing. People on the law of cosines forget that it's minus, right? Something plus something minus 2. And sometimes people just forget the 2. But make sure you learn those formulas correct. Y'all have a good one.